Hello guys, welcome to the next lecture of X.509. Now, this X.509 is a type of the digital certificate itself. In the previous lecture, we have covered the concept of what the digital certificate is and why it is needed, and how the concept of digital certificate is implemented. So let's begin with X.509. First, we'll see the authentication service and then we'll begin with the X.509 certificate. So X.509 authentication service. It is a distributed set of the servers that maintains a database about the users. The users which wants to log in into the session, the users which have already logged in and wants to start communication with the other users, such users information is stored in a database. Each certificate contains the public key of a user and is signed with the private key of the certificate authority. These type of certificates are very much useful in SMI for IP security type of the protocols, for secure socket layer protocols, for transport layer security protocols, and for the SID. RSA is recommended to use for implementation of such type of the authentication services. Now let's begin with X.509 certificate, which is a type of a digital certificate itself. Now, as we all know, the digital certificates are issued by the certificate authorities, that is CA. So X.509 is also issued by CA, which contains the version number, whether the certificate is of version 1, version 2, version 3. It also has the serial number, which is nothing but the unique number and which is being associated with the CA, which is being given to particular certificate by the certificate authority for identifying that particular certificate. Signature algorithm identifier it has issuer's name, it has the validity period, that is from which date to which date the particular X.509 certificate is valid, the subject name, the subject's public key, the issuer unique identifier, that is versions, that is nothing but the versions, subject unique identifiers, extension fields, and the signatures. Signatures are consist of the hash of all fields in the certificates, so that will be then considered as the final signature. For the notations, if we consider CA of A, that is in less than and greater than sign, if we are writing A, that means the certificate authority is issuing or has issued a certificate for a user A. So this is the exact notation, or this is one of the notation to give the particular user a desired certificate. This is the format of X.509, wherein you can see that the version, the certificate serial number, parameters, algorithms, issuer's name is given, the validity period is given, the subject name is given, the extensions, issue, subject unique identifier, and then at the end the signature, which is called as the X.509 certificate. Also in the figure you can see the certificate revocation list, that is the certification algorithm identifier is needed, the update date, the next update date, the revoked certifier, which is nothing but the user certificate serial revocation date, and the revoked certificate and the signature. This is an example of X.509 certificate, wherein you can see that whatever the entities we've seen just now is being properly given, that is the version number, the serial number, the signature which is being used, that is the signature algorithm which is being used, that is here the MD5 with RSA encryption has been used, the issuer, a server, what is the validity of it, before, after, what are the subjects, what is the subject public key information, which encryption methodology is being used, what is the public key, and then at the end, for issuing the signature algorithm, which particular encryption is used and which particular technique is used. Then at the end, we can get the signature. This is the standard notations. User certificates generated by CA use the following standard notations. That means the certificate authorities has to follow some standard protocols to properly assign a certificate to a particular user. That is, a certificate, if it is issued, that it should contain the certificate version number, serial number, CA, AI, and so on. Where Y of X is nothing but the certificate of user X issued by the certificate authority Y. That means Y of I, the signing of I by Y consisting of I with an encrypted hash code appended. If it is in the curly braces, it means that the hash code has been appended consisting of I by the authority for a particular user. How to obtain a certificate? That means a user, if certificates it has to be generated, then the user certificates generated by a CA, which should have the following characteristics. Any user with access to the public key of a certificate authority can recover the user's public key that was certified. That means it is very essential that certificate authority should be aware about the public key of a particular user. No party other than the CA can modify the certificate without being detected. It is very essential. And since they are unforgeable, they can be placed in a directory without the need of the directory to make special efforts to protect them. Now, CA also has to follow some rules. So this is the hierarchy which the CA has to follow. Both the users share a common CA. If suppose two users are there and they are sharing the common certificate authority, that means they are assumed to know the public keys of the users and the CA's public key also. So if X certificate authority is generating a certificate for user A and X is the same authority which is generating the certificate for user B, then A has B's certificate. That means A will be aware of the public key of the B. Otherwise, CA must have to follow the hierarchy. Signed by X1, B signed by X2. If A doesn't know X2's public key, B certificate is useless for A. That it is very self-explanatory, guys, because if two users are utilizing the same certificate authority and if they want to start communication, so they should be aware about the each other's public key and the CA's public key. Okay, so for that reason, the hierarchy has to be followed by the CA, certificate authority, for issuing the public keys and for knowing the public keys of the users also. A can obtain X2's public key from X1 if X is also signed by X1. That means it is very essential to use the signatures. It is very essential to use the proper hierarchy while issuing the certificates to the users who are sharing the certificate authorities. Use certificates linking methods of hierarchy to validate other CAs. Each CA has certificate for clients that is forward and parent that is backward. Each client trusts parents' certificates. Enable verification of any certificate from one CA by users of all other CAs in hierarchy. That means we have to enable the certificates, we have to enable the verifications of any certificate if it is being issued by one CA or by other CAs, which are following the proper hierarchy. This is the hierarchical diagram. Here you can see if a certificate is being issued by X to user A, then A knows X's public key. That means certificate authority's public key is known to the A. A can get all the public keys signed by A because A is using the certificate authority X. So A can get all the public keys which is being generated by X, or which is being signed by certificate authority X. A establishes a certification path to B. That means if A wants to start communication with B, so A should have B's public key, which it can very well get it from X because that public key of B is also signed by X. B establishes a certification path to A because now A and B knows each other public key because they are being signed by the same authority, and that authority's public key is also known to the user A and B. This is what is being depicted in the figure. How the revocation of certificates takes place and why. The reasons are here. The user's private key is assumed to be compromised. The user is no longer certified by the CA, and the CA certificate is assumed to be compromised. If any of these reasons are there, then there is the revocation of certificates can happen. Now, what is the authentication procedure that these certificates do follow? X.509 certificate includes 3 types of the authentications. They have different alternatives to the authentication procedures, and they are one-way authentication, two-way authentication, and three-way authentication. Obviously, all of these authentications uses the public key signatures. One-way authentication in general is like if two communicating parties are there, either of the communicating party will be authenticating itself. Okay, one message A is sending to B used to establish the identity of A and the messages from A. Message was intended for B. Integrity and originality of the message is being achieved. Message must include timestamp, nonce, B's identity, and is signed by A. What the timestamp is? Timestamp is nothing but a message and generation and the expiration time for that particular message which is being sent by a user A for user B. And in one-way authentication, user A will only be showing its identity to user B. For showing its identity, that particular user A will send a message which is intended for user B, and it is the responsibility of the user A only to ensure the integrity and the originality of the message for the intended receiver, that is B. And nonce's value must be unique with the expiration time, and this is a technique used to detect a replay. Nonce is nothing but a newly generated number which is every time generated for every transformation of the message. For every newly generated message, a new nonce is being created. It may include additional information for B that can be any session key also. Two-way authentication. If both the parties are communicating with each other, then both the parties have to identify each other's identity. Both have to introduce themselves, both have to authenticate themselves. In this case, A will also send a intended message for B, sending its identity, and B will also send an intended message for user A, sending its identity. Both of the messages should ensure the integrity and originality for each other. Reply includes original nonces from A, also timestamp, and nonces from B. If A is sending a message to B and if B reply backs to A, then B will have to use the nonce which was generated by A for B, and obviously the timestamp also needs to be sent from B to A. It may include additional information for the other user. Three-way authentication. A is authenticating to B, B is authenticating to A, and then A has to reply back to B with the acknowledged message. That is, the three messages are used to enable the three-way authentication without synchronized clocks, and has a reply from A back to B containing a signed copy of nonce from B. That means the timestamp need to be checked and very much relied upon. Every time when A is sending its identity to B, and when B is sending its identity to A, when A receives the authenticity or the identification message from B, then A has to reply back to B. And it is the responsibility of A to use properly signed copy of the nonce from B when it will be replying back to B in the third message. So this was the three-way authentication. This is the figure where you can see how the authentication processes has been followed by X.509, which are considered as the strong authentication procedures. Thank you guys. I just hope that you might have got the concept of the digital certificate and the type, that is X.509 certificate also. Thank you.